simple AC circuit. We did two videos that explain the full idea behind simple AC circuits. This video is all about solving problem past question with the idea we have learned so far under simple AC circuit. It says a circuit having a resistance of 8 ohms and inductor of 0.5 meter Henry and a variable capacitance in series is connected across 200 volts 500 Hz, that's hertz supply. Calculate number 1 the capacitance of given resonance. 2 the voltage across the inductor and capacitor. So alright, we said your first step in science is to list out the givens, right? In this case, it says a circuit having a resistance of 88 ohms, please, 8 ohms. So the first thing there, I'm given 8 ohms, so that's resistor or resistance 1, 2. That's R. R is 8 ohms. It says an inductor that's of 0.5 meter H, that's millihenry. So that's inductor L is 0.5 millihenry. This gives you 0.5. Milli is times 10 to the power minus 3. L is inductor symbol. Alright, I have it this way. Millihenry per se, Henry. H here. Alright. Next up, a variable capacitance. So we're looking for variable capacitance. C is unknown. In series is connected across 200 volts, and so the volt there is 200 volts, and frequency, because that's Hz, that's hertz, that's frequency. F is what then? 500 Hz supplies. So I'm asked to calculate for capacitance to give resonance. So let's do for A. I, so one says the capacitance to give resonance. All right. Alright, that was this. When it comes to resonance concept, resonance idea, or frequency resonance, the idea there is that I'm equating XL with SC. That was said in a previous class. So that is, from here I will have SL equal to SC. What's SL? You know that SL is what? 2 pi FL equal to SC is 1 over 2 pi FC. I have this. Right? So proceed from here. I'm actually looking for C, that is the capacitance to give resonance. That's C. Right? So how do I get C? Of course, C is here. I can see C here. This is C in this case here. So 2 pi is a constant. F is given as 500. F is also given here as 500, right? So the task now is just to substituting. That's all. So okay, it's 50. F is 50. Okay, F is 50. Please, F is 50. The frequency is 50, please. 50. F is 50. Hz. So I have 50 as F. So put in your values, what do you get? This gives you 2 pi, F is 50, into L, the inductor, is this value, 0.5 times 10 to the power of minus 3, equal to 1 over 2 pi into F is 50, 50 into C, This is what I'm looking for. So I have C. Now multiply this one here. Multiply this one here. This everything here gives you 0.157. This is now equal to 1 over multiply 2 by pi by 50. Of course, pi is 3.142. Multiply by 2 by 50, I will have 100. It gives you 100 C. Right? So in this case here, if I want to, I'll multiply. So multiply here, cross multiply. What do I get? Take this off. Take this one off. When I take this off, I will have that. This gives 0.157 times 100C equal to 1. Alright, multiply the two together. Multiply these two together. I have about multiply 0.157 by 100. This gives me 15.7C equal to 1. I want to get C. Divide by 15.7. This man cancel this. I'll have that C, which is the capacitance of the resistance, is equal to 1 divided by 15.7. This gives me 0.063. Capacitance is measured in farad, so I have F here as my farad. So this is the value for hold on. At this point here, multiply this one, I have this. It gives you 1 over 2 times pi. 2 times 50 alone gives you 100. 2 times 50 gives you 100. So there's still a pi. The pi and the C will remain, right? Yeah. So I have to multiply this one here by this 100. So I still have pi left. So pi C equal to 1. Alright. So the mistake there. So here should be 2 times 5. 2 times 50 gives you 100. The pi should be left, right? So from here, this will give, multiply pi by, this is 3.142 is pi by 100 times 100 times 0.157. This gives me 49.32 what's it called? Capacitor equal to what? 1. Get C divided by 49.32. 49.32. This cancel this. C will be equal to 1 divided by 49.32. This gives me 0.020, perhaps. I want to look at 0.0023, perhaps. Alright, F. I have this piece. So this is how this works. So this is the value for the capacitance to give resonance. Alright. Proceeding from here, let's get second part. Says the voltage across the inductor and capacitor. Let's get the voltage across inductor and then capacitor. Number 2, the voltage across the inductor and capacitor. Alright, so in this case here, we have two things here. Voltage for inductor, voltage for what? Capacitor too. So here's the idea. For inductor, that's voltage, that's VL equal to I dot what? SL. XL, this is for inductor. For capacitor, that gives you VC equal to I dot what? SC. That's the idea. So here's the idea. To get VL, I need current. Multiply the current by SL. But here's the idea. From Ohm's law, V is equal to IR. Observe that this is for resistor, this is for inductor and capacitor. The currents are the same, I. So the currents are the same. So this is that I can use this one here to get current and insert the value of current into this to get VL and VC. So from here, we know that V is they give us V as 4, V as 200. So from here, V is 200 equal to I is unknown yet. Dot what's R? R is 8. R is 8. So just divided by 8 by 8. Let's get I. I now is equal to 8. So 200 over 8 gives you 25 ampere. So I've gotten current as 25 ampere. I'll put 25 into this place and this place here to get VL and VC. So let's get VL first. For inductor, let's get VL for inductor. So for inductor, that's VL is equal to I dot XL. SL. What's I? Of course, 25. That gives you 25 dot. What's XL? SL is given in question. SL is, okay, we know that SL is 2 by FL. This is now equal to 25 times 2 times pi times frequency is 50 times the L there, the length there is 0.5 times 10 to the power of minus 3. The VL here, voltage across inductor gives you 3.927 volts. That's your answer to this. Let's get for capacitor. Voltage across capacitor, that's VC. Let's get VC. We know that VC for capacitor, remember that VC is equal to I dot SC. This is equal to I is of course 25 dot SC is 1 over 2 pi FC. Alright, put in value. 25 times 1 gives you 25 all over 2 times pi times F is 50 times C. What's C? We got C value. We got C to be 0.0203. That's our C. From here, VC will be equal in value to if I divide everything here, it gives you 3.94 volts. Alright, I have 3.94 volts. This is a solve this particular question. This is the idea of simple AC circuit. See you guys in our next class. If you find this class helpful, do want to like this video, share it to your friends and classmates, and subscribe to my YouTube channel. See you guys in our next video.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen,